I'm Dr. Mahesh Babu, Professor, Department of Civil Engineering, NARASIMHA REDDY Education Societies Group of Institution, Integrated Campus, Hyderabad. Structural Engineering. In Unit 4, I explain different type of problems. In this video, I explain different type of column design. Circular column with helical reinforcement. This is class of 39.4. That is IS 456. Here, if you see this class 39.45 clearly explain how to design helical reinforcement of a circular column. See, always you should thorough with this IS 456. Here, if you see 39.4 compression members with helical reinforcement. This is very important point you have to remember. That is here. Always you must remember this one. The strength of member of helical reinforcement shall be taken by 1.05 of the above this one. Okay. So from the above formula, we have to take 1.05 times of that is 0.04 this FCK and AC plus 0.067 FY point SC. This is multiplied by 1.05 for helical reinforcement. So this is way, and we have to check for here 0.36 by multiplied by AG by AC minus 1 multiplied by FCK by FY. So this is AG is total cross section area of the section. AC is the area of the concrete section. FCK is characteristic of concrete. FY is characteristic of helical reinforcement, and it should be used only Fe415. So this way we have to consider this helical means this core. This is shell we can call. Internal is core. Outside is a spiral. So you can say if it is like spiral, right? So this is called spiral, right? So from this 39.4 we have to design. How to design a short column? We'll see one problem here. Design a short helical reinforcement circular column with minimum amount of longitudinal steel to carry a factor axial load of 3000 kilonewton with both ends pinned, and use M25 F415 also determine unsupported length. Now how to calculate? Say as per class this 39.4 here, what is given 1.05 multiplied by this equation. Same thing here you have written PU equal to 1.05 into 0.04 FCK AC plus 0.067 FY ASC, where FCK is characteristic of concrete, AC is area of concrete, FY is the characteristic of steel, that is maximum of 415, and AAC area of compression steel. So, and here in the problem is given as factor load PU is given, that is 300 kilonewtons, and A is equal to, as you know, circular column area is pi d squared by 4. So how to calculate pi d squared by 4? That is area of cross section of column. Then how to calculate this area of compression steel? Assuming here area of compression steel provided is minimum 0.8%, because for all columns 0.8% to 0.8% to 4%. So whenever overlaps are there, up to 6%, but maximum 4%. So 0.008 into pi d square. So now area of concrete will get total cross section of area of concrete of the column, cross section of the column minus area of steel. So here you should take is a common pi by 4 d square 1 minus 0.008. This is minimum reinforcement we are going to provide. We will check. This is the limit state method. Now area of concrete you will get is the AC minus SC. Now AC equal to 0.992 by d square by FK is FCK 25 MPa and FY equal to 415 MPa. Now, if you will get P equal to 1.05, 0.46 FCK, ASC, AC plus 0.67 FY, SC. Here, if you observe, you substitute all values here, you will get D value. Okay, this is from this step. Okay. Now in step 1 we calculated PU. This is PU equal to D. You will get 547 and provide 550 mm. Now area of longitudinal steel is 0.08 minimum, and this is equal to 1900 mm square. Then provide say 10 bars of 16 mm. 116 mm is 201 mm square. So like that, if you provide 10 bars, so it is more than 1900 mm square. Provide 10 numbers of steel bars. Now what is pitch? Assume 8 mm bars, clear cover, LX 40 mm. So volume ratio DC equal to here 500 minus 40 into 2. Here if you see, here total is 500 minus this 40 into two sides. We will get here that is 470 mm. 550 minus 80, 470 mm. And diameter of tie spiral is 8 mm, and area of that tie bar wires, that bar is pi by 4 8 square, that is 50 mm square. 8 mm bar is 50 mm square. So volume of 1 LX loop equal to pi minus DC and minus ASB by SP. That is 470 mm is here. If you see outer to outer, and you have to take center of this ring, center of this ring diameter is 8. So you have to subtract those 8 mm from here, that you are going to get one loop. So one loop into 50 mm, you will get volume of LX, that is VU. Volume of core is equal to nothing but pi by 4, that is P into, that is 8 mm into DC square, that is 7 to 75 ratio you will get divided by 173. 494.5 P is equal to 0.418 P here. Okay, so this is volume of the core, and here you have to calculate gross area. P is equal to 0.36 AG by AC minus 1 FCK by Fy. Here A is equal to B by 4 and A is equal to B by 4. VP this will get cancels. So you will get this answer. So 0.36, 1.37 and 25.41 by, that is 0.008. Pitch is, that is 0.418 by P, that is 0.00824. P equal to here 52 mm. So pitch is calculated from this equation. So height, anyone, grass or this one. So pitch of the area you can calculate this as a 52 mm. Now check spacing. As per P should be less than 75 mm and less than 1/6 of 470 mm, 78 mm, and it should be greater than 25 mm and greater than 3 bars of 8 mm bar 20 mm. So provide 50 mm and it should be less than 75 mm and it should be more than 3 times of bar. So provide 50 mm of center to center of this tie bars. See, first we calculated from the equation 1.05, that is we got what is the steel required. Then we calculated volume ratio of LX1 loop and volume of the core we calculated, and we calculated AC by AC minus 1 FCK by Fy. This we calculated, as we know that see general pitch in the given in the problem 25 mm, but in the not given, so we have to calculate pitch here. Pitch is designed for 50 mm here, and check for unsupported length. Now see what is LE 12D. 12D is equal to 12 into 550, that is 6,600 mm. Now minimum eccentricity requirement L by 500 plus, that is D by 30, that is 550 into is equal to 0.05 into 550. So A is equal to 4,000 83.3 mm. Hence L equal to L. So here 4.5 meters, which is less than 6.6 meter. So this holds good. It is a short column. So in this way, we have to do problem by adopting our the formula 39.4, area of helical reinforcement of column measured outside diameter, and age is cross sectional area. Age is cross sectional cross section area. So AC is area of core helically reinforcement measured the outside diameter of the helix. This is outside diameter of the helix. Okay, and age is cross area of the section, and we have to find here Vg by volume of core and volume ratio, volume of helix, volume of core. If you know pitch, we can pitch into area of that one. But here we have to calculate as a P, and we can calculate volume ratio. From that you will get this value 0.0082 from the pitch. Here if you calculate anyone, you will get P equal to this one. So as here you will get this value, you will get P, this value P equal to 50 mm, and it should be according to condition as per IS 456 26.5.32. Here if you see 26.5.3, here 26. Design consideration section is design consideration. You have to check this one. If you check this one, you will have these conditions 26.51. Okay, if you see they have given what is the maximum distance we have to provide. So according to this requirement for reinforcement, we have to provide for compression member stirrups. Okay, so in this way we have to solve the problem. So this is the diagram where we are providing 10 bars of 12 16 mm and 8 mm type bars at 50 mm. I will end with this. Will complete this in it. Thank you all.